so in this video we're going to tackle vector properties. So we're going to go over a few rules and laws that will be used in calculus when we are dealing with vectors. More specifically, when we're dealing with vectors, algebraically, or when we want to simplify algebraic expressions, when we want to add or multiply, vectors. So let's write down some rules. So let's say you have vector A and you have a vector B. This is called the commutative property of addition. Which basically states if you have a vector A and B, this can also be written as B plus A. Because remember, when you want to add this one to that one, it's the same as adding that one and this one. So that is one. The second is the associative property of addition, which is, remember, from our polynomials. Actually, that was a while back. Let's say you have these three. Well, this is the same as saying that this is the associative property, implying that these two are associated. That's the same as these two being associated in this expression. We also have the distributive property of addition, and that is going to be if we have a k, which is a number, and that's being multiplied by this. The distributive property, if you remember, when we covered multiplying binomials, k can multiply into this binomial to give us ka plus kb, where k is any real number. What else do we have? We have adding a zero vector, which is pretty straightforward. If you add a to a vector of 0, that is still a. What else do we have? We also have the associative law for scalars. And this basically says that if you have m multiplying times that, m and n are both real numbers. They're different numbers, but if you have it multiplying like that, the only vector here is a. That is the same as saying m times n times the vector, but it's also the same as saying mn times a. And then the final one, I guess, we have is the distributive law for sample here. We can do a few examples. Well, let's do 2 examples here. Let's do this one using these laws that we've learned so far. Let's say we have 3 times 2a plus b plus okay, now all I want to do now is simplify this expression, and this is going to be very straightforward. So let's open up this first using the distributive property. So that's going to be 6a plus 3b plus 3c minus, I'm multiplying a minus 1 into here, minus 3b plus 2c. Now we can start moving them around using the commutative property. It's hard to say. Plus 3b, and then we have minus 3b plus 3c plus 2c. So, and I know it looks pretty straightforward just to start adding them, but I want to show you the distributive property for scalars, which is that and that. So now we have 5a plus 0b plus 5c, and 0b is basically the same as this. It's a 0 vector, so we can get rid of that, and we're left with 5a plus 5c, or it could also be 5a plus c, whichever one you want. We could do another example. Say you want to do x is equal to 3i minus 4j plus k. And let's say y is equal, I'll put them here, y is equal j minus 5k, and let's say we have z, which is equal to negative I minus j plus 4k. So let's do x plus y. So if we write out x plus y, it's going to be, 3i minus 4j plus k plus j minus 5k. So I this up, you would get 3i minus 4j plus k plus j minus 5k, and that would give you have 3i, and then you have j plus negative 4j plus j. That would leave you with negative 3j, k minus 5k. That would be negative 4k, and that's your answer. You could also do the same except x minus y. But when you open up the brackets, now these are negative. The sign flips for that one. And now you're left with let's see, 3i stays. We have negative 4j and a negative j, so that becomes negative 5, and then we have k and 5k. That becomes 6k. Now we can do one that's a bit more complex. Let's try x minus 2y plus 3z. So this is going to be a long one. So remember, our x is 3i minus 4j plus k minus 2 times y. And our y is j minus 5k. Where are you? Let's take this. What was it? Plus 3. Negative I minus j plus 4k. So let's open this up. So we have 3i minus 4j plus k minus 2j plus 10k. And what else? Negative 3i minus 3j plus 12k. So now that you have our I, we have 3i here, and then we have a negative 3i here, so the i's will cancel. That's good. We have negative 4j minus 2j minus 3j. So yeah, it's actually very straightforward to do these things. If you want to try one for yourself, you can try this one and put it in the comments, see what you get. So this is all one. You can try that on your own. 3 times a minus 2b minus 5c minus 3 times 2a minus 4b plus 2c minus a minus 3b plus 3c. So that will conclude today's